inverse functions and relations. So when we're thinking about inverse functions and relations, we want to be thinking about flip. That's not how you spell flip. Let's try again. So how about flip it over? All right, so we're trying to think about flipping it over. So flip it over what? What are we talking about? Let's see if we can make that a little bit more clear. So we are talking about exchanging the domain and the range. Okay, so in practical terms, we're taking x and we're putting it where y is, and we're taking y and we're putting it where x is. Let's see what we mean straight up with an example. First of all, a piece of notation before we get to the example. If f is the function we're talking about, then we write f inverse. This is the most confusing notation in all of mathematics that I am aware of, because this does not mean f to the negative 1. Usually you'll see it all written out in full notation. So this is f of x, and then to write the inverse, we write f inverse of x. Gee golly, will occurs. Thanks, mathematicians. So now that that's out of the way, let's look at some examples real quick. Okay, so we're going to start out with this example. We're going to say find and graph the inverse of f of x equals 1/2 x minus 3. Excuse me. So the first step when we're doing this is we want to get rid of all our functional notation, because it's just going to cloud everything up. And so we're going to rewrite this as y equals 1/2 x minus 3. Okay. So then after we do that, we're going to take and we're going to switch the y and the x. Okay, we're going to end up with x equals 1/2 y minus 3. Now, in order to graph this, we're going to want to put it in slope-intercept form, so we're going to solve for y. So to solve for y, the first step there is going to be to add 3 to both sides. So plus 3 over here and plus 3 over here. Now, to make it a little bit more normal, I'm going to go ahead and switch everything around to the opposite sides as well. So we're going to be left with, over here, we're going to be left with 1/2 y equals x plus 3. So you see what I did there? We took and we canceled this 3 and put it over here, and then I rewrote it the other way around just so that it was more clear. Now, to get rid of this 1/2 over here, we have to multiply everything on both sides by 2. If you're going to make a mistake, you're going to make a mistake of not multiplying everything by 2 over here on this side. So the inverse of y equals 1/2 x minus 3 is y equals 2x plus 6. Okay, so when we graph those, it's going to look something like this. Okay, so you can see this blue line right here is, in fact, our original one that we were starting with, y equals 1/2 x minus 3. And then the other one, the blue one, so this one is y. Let's make something that you can see. y, this is y equals 1/2 x minus 3. And then the blue one is our inverse, y equals 2x plus 6. This dotted line right here in the middle, for comparison's sake, and where it's actually a little more than that, which we're going to see when we do our next example, is the parent function. Parent function, y equals x. Okay, so let's clear all this off and look at another example. Okay, so this is going to be our second example. We're going to look at one with a quadratic in there this time. So we're going to find the inverse of f. Got to switch back to a clear color on this screen. F of x equals x squared plus 1. All right, just like before, we're going to start by rewriting this as y equals x squared plus 1. Then we're going to take and we're going to switch the y and the x, giving us x equals y squared plus 1. Now we're going to solve for y. So to solve for y, we're going to add 1 to both sides. Just like before, we're going to go ahead and rearrange this as well and end up with y squared equals x plus 1. Now to get rid of that squared, the opposite of squaring something is square rooting something. Okay? A common thing to forget here is that when you take the square root of both sides of an equation, you end up with a plus or minus. So we end up with y equals plus or minus the square root of x plus 1. Okay? So at this point, you may or may not have seen square root functions graphed yet. So just a quick primer. The parent square root function is y equals the square root of x. And it looks like this. Looks like this. Let's do it in bright blue. So it's totally different. Okay, so that's the parent there. Y equals square root of x. So it's kind of a half a parabola. So if you have plus and minus, it would be a full parabola going sideways. So if we graph them all together, we end up with this shape. Okay, so this is our original up at the top. Our original was f of x equals the square root of x plus 1. So it's it wasn't the square root of x plus 1. Try again. It was x squared plus 1. That's going to make a lot more sense, huh? Okay, so y equals the x squared plus 1. So it's a parabola shifted up 1. Then the inverse of that was y equals plus or minus the square root of x minus 1. Okay, so it's a square root function on top and then a square root function on the bottom, giving us a sideways parabola. Now you'll notice I've also drawn y equals x on here, this dotted line. And it's really, really clear when you see this one. And if we go back a couple of levels and we take a look at the linear one, you see very clearly at this point that what an inverse does is it takes and it reflects the graph over the the line y equals x. So it took this graph and it reflected it over here. That's what an inverse does graphically. That makes sense? Good. I'm glad it does. Okay. So let's go back all the way and let's kill off our linear graph and go back over here. Oops. Sorry. Go back over here. We're going to delete all of that. Now, let's look at an example of trying to find out if one function is the inverse of another function. Okay, so in order to do that, let's get a half-decent color, and let's have f of x equals 4x squared, and let's have g of x equals 2 times the square root of x. And we want to know, are these two inverses? Okay, so in order to do that, we want to find f of g of x and g of f of x. I'm going to see if I can fit these both on one deal. We'll see if that happens or not, but we're going to give it our best shot. Okay, so to find f of g of x, remember from before, what we do is we take and we put g inside of f. So we're going to write down f with parentheses where f is. So it's 4x squared. And then we're going to put g on the inside of that. So that would be 2 times the square root of x. All right, this one happens to be quite easy. Okay, so we bring down the 4. 2, the squared out here applies to both. So 2 squared is 4. And then square root of x squared, the square and square root cancel, leaving us with just x. So then we have 4 times 4 equals x. Now, we can already see, now you may not know, but we can already see that these are not inverses. Because if these were inverses, then their composite would be the identity function, which is f of x equals x. So it's that same line. So it should equal f of x equal x. So these are not inverses if it doesn't equal x. Okay, let's look at another example. Let's look at f of x equals 3x plus 9. And for our other one, let's do g of x equals 1/3 x minus 3. Okay, so we want to know if these are inverses. So remember from just a minute ago that if they are inverses, then their composite is going to equal the identity function, f of x. F of x equals x. So let's find f of g of x. All right, so we're going to start out by writing f of x with parentheses. So it's 3x plus 9. And then inside the parentheses, we're going to put g of x. We're going to put 1/3 x minus 3. And let's go ahead and take that one on down. Okay, so we're going to distribute the 3. And we get, so 3 times 1/3 x is 1x, or just x. And then 3 times negative 3 is minus 9. And then we bring down the plus 9. Now it's looking hopeful because negative 9 plus 9 is x. So that one works, so let's double check the other one. Let's look at g of f of x. We have to check them both because they have to both equal the identity. Okay, so equals 1/3 x. Now we're going to put parentheses and then minus 3. And then inside we're going to put f of x. So it's going to be 3x plus 9. Sorry for the cramped conditions, trying to squeeze these all in one space. We're going to distribute the 1/3. Okay. So 1/3 times 3x is 1x. So we've got x. And then 1/3 times 9 is going to be 3. So plus 3 and then minus 3. Oh, those are going to cancel because 3 minus 3 is 0. And we end up with x. They are inverses. Yay. Happy, happy day. That's going to be it for this video. We'll see you in our next video where we flesh out some of those square root functions just a little bit more than what we did in this video. We will see you there.